Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So we have the maximizing the number of target nodes after connecting trees. So you just go through the description. Once I am explaining you in this example that what we need to return is a vector, and that vector will process each element of tree1. The tree1 has n nodes and tree2 has m nodes. We will go through each of the nodes in tree1 and see which and see to connect that node with some node in tree2 and see that within a distance how many nodes are there, and we need to return that number of nodes in the ith output. So let's say for node 0 here, for node 0, if you see k is 2 here, so within the distance of 2 means that within 2 edges, all the nodes are possible to reach from this tree. So there is a total of 5 nodes you can reach, including itself. You have to include itself also. And if you connect this 0 to this 0, you also see that you traverse through this edge first and then to the neighbors of 0. So you get to traverse these 4 nodes also. You get to traverse 0, 1, 2, 3 nodes also on tree 2. Okay, so you get 5 nodes from tree 1 and 4 nodes from tree 2. So you get 9 nodes total for this node number 0. For node number 0, you get 9 nodes total. So the first output in the vector is 9. So this was the problem description. Let's try to look at the approach of how you will solve it. The hint is that you have to use BFS, and if you know BFS properly, this should be a brute force solution. So let's just try to start. So yeah, let's try to think what can be the approach. So let's say we have a tree here, starts from 0, 1, not necessarily in order. It may be like 4 is there first and 2 is there, 3 is there. You have, let's say, a 5 here. You have this tree, and you have some tree here also, which is 0. Let's say 7 is there, 2, 3, 4, and let's say 5. And another could be, let's say here it is 6. Okay. So you see, when you go through this node, the n and m, if you know that this has n nodes and this has m nodes, and both are of the order of 1000. Both are of the order of 1000. So this means that you can do the time complexity of O of n square, you can do O of m square, you can do O of n into m, whatever. Okay, so that's quite obvious. These things you can just go through. So that's why this becomes a brute force solution, if you see. So what you need to do, you need to find the k distance. Okay, how many nodes are there within the distance of k? What you need to do, how many nodes are there within the distance of k? So if you know BFS, you start from a node, you go to the nodes which are in the neighbor. You traverse, it is a level order traversal, you know that, right? So first you go through these all nodes. Then if there are some connections more, you go through these all nodes. That's how you perform BFS. So and you perform it by pushing this into queue, right? So you can just do that, like for every level. So you can say that you traverse this first level and you traverse this second level, and you need to traverse k levels in the BFS. K levels in BFS. Okay, all you need to do is traverse k levels in BFS, and every time add the size of the queue. So initially the queue has 1 element here, you add size equal to 1. Then the queue has these 3 elements here, you add size equal to 3. Then the queue has these 4 elements here, this element, this and this. So you add 4. So in this way, whenever this is the initial node, this is k level 1, this is k level 2. So whenever you have reached k whenever you have exhausted k, you can just do k minus minus in every step. Whenever you have exhausted the value of k, you just break out from the loop of that BFS and you just tell that. So what you can do here, you can see that suppose you can, which node should you connect to every node. You can see that suppose there is a node, let's say after this, let's say 8, and this node has many branches. So you see, always you should connect some node, to this node only, so that after traveling from 4 to 8, you can you can cover maximum number of nodes, right? So you need to return the maximum number of nodes only, like from by which two nodes should I connect to get the maximum number of nodes by within a distance of k. So you traverse this distance, let's say distance is 2. So you guys traverse this as 1, and this all is at a distance of 2. These all edges are at a distance of 2 from this 4. So always the thing is there, always it is optimal to connect to a particular node, in tree 2 always. Okay, always it is optimal to connect to a particular node in tree 2 which has maximum branching, not k level neighbors, which has maximum k level neighbors. Okay, so what you can do, you can write a function which takes a adjacency list of a graph, which takes a ith node as the starting vertex, and which has also the n or the m value and also the k. Okay, so what you can do in this adjacency, in this function, you can find the number of k level nodes. Okay, and I already told you how to find the number of k level nodes by iterating through this BFS. Just you will do the BFS to the starting nodes, and you just find the k level nodes. Okay, so what you will do, at first you will iterate through tree 2. At first you can just iterate through tree 2. So what I can tell you is that you can just ignore this one. I am just using a different one, not this this one. Okay, so yeah, so what you can do, as I told you, you first you go through the tree 2. You will go through tree 2, and for every node you run the function. And store a max value as the max count. Why you will store the max count? Because to that will be the max number of k level nodes, and in that is the count which we will add every time for every node of T1 node. For every node in T1, add the same count. Okay, as I told you that it is always optimal to connect to a single node. Then what you can do, you traverse through every element. So this, you know that for every node you are running the function is taking O of m time. Okay, through perform a BFS for starting from every node, so you get O of m square here. And then you come to tree 1, traverse through every node of tree 1. So then again traverse through every node of tree 1 and see, count k level neighbor. Again run the function count k level neighbor. So you need to again run the function k level neighbor, and to this count you will add the max count, because after connecting, and also you need to remember that, so let's say you have a tree here, and you are connecting to some other tree, connecting to the nodes of some other tree. Okay, so if you are starting from this vertex, and let's say k is 2 here, so you can traverse through this, okay, all of this. But once you connect this, one iteration, one value of k is always lost by jumping from this node to this node. And when you are giving this node to the function, then you have to do k minus 1. So if it is k here, you have already used one value of k, so you will find k minus 1 level node from here, okay, in this graph. So you will always, in M graph, you will always look to find k minus 1 node. So whatever that will be explained in more detail while we code. So yeah, you traverse through each of the node and just add the max count and store it in a vector. Store these in a vector array. Answer of I, answer of node I, you go to the node I and store all the values of the count. So things will become more clear as I code. So I think you did understand the approach. It is quite an intuitive one. It is almost a brute force solution. But the implementation might be different. You are not given the value of n and m also here. So you need to extract the value of n and m from edges. So maximum value from all the nodes, you just take the maximum value for all the nodes and add 1. So here n is 5. As it goes from 0 to 4, the n must be 5 here. So yeah, that's all. What you need to do is initialize n and m as 0 first, and then you can just go through all the edges 1 dot size, and what you can do n equal to max of remaining n edges 1 of I0, this is the first vertex, and edges 1 of I1, this is the second vertex. So you go through and find the value of n. Similarly, you can also find the value of m in a really similar fashion. All you need to do is change all the 1s to 2s because they're traversing in the different graph, and get this value of m also. Okay. Now, definitely in order to perform a BFS, you need adjacency list. So let's try to create the adjacency list. We have a vector of vector, and you have adjacency list of 1. You also have adjacency list of 2. This is the tree 1 and tree 2. So what you will do, you will just fill out the adjacency lists. Okay. Again, the same loop, same kind of loop you need. So you can just copy it from here and change the contents of the loop. Yeah. So you have an int u. This is one vertex. You just extract the vertexes first. And what you can do is adjacent u vertex is adjacent to v. So you put this in the adjacency list. Also, you push this into the adjacency list of this. Okay. As it is told, it is an undirected tree. So both sides must be pushed. And on a very similar node, you can create the adjacency list of the tree 2 also. Things will be really similar here. So one thing you need to take care of is this ADJ1 and ADJ2. This is for ADJ1 and this is for ADJ2. Okay. So you got it. The graphs are, the trees are now ready. All you need to do is first write this function k level nodes. So count k level nodes. So you write some function like this, which will count k level nodes. What it will take? It will definitely take an adjacency list. It will definitely take an adjacency list. It will take the starting vertex. it will take number of nodes. It will take k to be particular at first, and then number of nodes maybe. Yeah. So you are performing a simple BFS. So all you need is a queue. You need a visited array. Must not forget this. You need a visited array to say that which node you have already visited. You won't visit back that later. And what you do is you do q dot push starting vertex. You push the starting vertex at first. You initialize a count, which you will, which in fact you are going to return later. Okay. And then you go through the loop of, this is a standard BFS which I'm doing. And what you do for counting every, so you need to take care of the levels also, right? So you do size. You find the size of the key at first and do while size minus minus. What will happen? This loop will always iterate through one particular level. So that way we can keep a track of every level and do a k minus minus at the beginning, at the end. We are finished processing every level and then we do k minus minus. Okay. So this is also standard BFS level orders when you are k level BFS sort of thing. You must have done this if you have done BFS earlier. So if I am extracting the node q dot. So if you don't know, just writing, this is the method of k level wise BFS. K level wise BFS. If you need to track every level, okay, while tracking every level also, you need to perform this. If q dot push, not push, q dot front, you are extracting the front element of the queue and in the node, and just doing q dot pop. These are the standard things. Okay, and now what you will do? You will just go through every adjacent nodes of queue, adjacent nodes of the nodes. So for auto adjacent node of the adjacency list of node, I will go to the adjacency list of node, see what are my adjacent node, and say that if my adjacent node is not visited so far, I can push the adjacent node. I can also say the adjacent node is now visited, so I mark it as visited. Okay. So yeah, we have that. And what I will do here, I will also mark the visited of the starting vertex as 1. Visited of the starting vertex as 1. So yeah, we have it. So the size of the queue, as I told you in the explanation part, that you need to add the size of the queue, right? Every time. So that's how we will track the k level nodes. So count, first of all, count will be initialized to 1 if you think. Why so? Because if, let's say, you are having k, like the itself node, you also need to count, right? You are going through the neighbors, counting the neighbors, but you also need to take care of the node which is itself. You need to add that too, right? So to this one, you will add every time a q dot size. To this one, you will add every time a q dot size. And if you find ever that k is less than or equals to 0, or it is going to become 0 or some sort of thing, you just break the loop. Okay. No need to traverse any further, and you just return count. So one thing you need to take care of, like what if k is 0 or 1 here? Those things you need to take care of. So let's say, how can k be less than 0? So as I told you, I am passing k minus 1. So if k is given 0, and it's k minus 1, it means that we cannot traverse anything. So if k less than 0, you just return 0. You are not able to traverse anything. And if k equal to 0, it means you are in a particular you are in a particular node itself. You are confined to the node. So you return 1, the count of that particular node only. Okay. So yeah, we have it. We have this thing. So I will count the k level nodes. So what I told you. Now first traverse through T2 to find optimal node to connect. Okay. So that will be the one which is having the max number of nodes. So I will have a max count variable. And what I will do is very simple. I will just go through 1 to m minus 1. And for every time I will find this k level node. For every time, what I will do is I will find this k level node. And for this node, what I have the what all things do I have? I need to pass adjacency list. DJ2 I will pass. The starting vertex is I here. The num k is k, and k should be k minus 1 as I told you, and it should have value of m. Okay. So I have already clearly explained you in the explanation about these things, why it is k minus 1 and all. What you do? You update the max count. Just update the max count with this count. And what you need to do is now simple. You need to traverse through every node and just add the max count and just store the answer. Okay. Answer should be of length n is told in the question. So thing I am doing is really simple. I will just iterate through all the nodes. Now I will iterate through the k nodes. I will pass adjacency list 1. And what I will store is that answer of I will store it to be this count plus max count. Okay. So I'm traversing in the my tree also, and I am after connection in I am going to the other tree and traversing with the value of k minus 1 and adding both the answers. Okay. And what you do is just return answer. So let's see if there is any error or this works directly. Okay, so I have some semicolon issues. Copy pasted this, so this would also have it. Let's try to run it now. Okay. I did not do this max count. Now will it be fine? Okay, so we do have a runtime error. So let's try to see that why it is giving a wrong answer. I'm traversing through every node. I am adding the count to max count. I'm storing it in the value of answer. This portion is completely fine. This is having k minus 1. And it is storing the max count value from count. Yeah, this is also correct. So okay. You have adjacency of okay. So what you need to do, you need to increment n and m also, because I have just selected n and m value as the max value among all these things, right? But you see here, it goes from 0 to n minus 1 and m minus 1. So I have the value of not exactly m and n, but m minus 1 and n minus 1. So I need to increment that. So if I have n and m now, then it goes from 0 to m minus 1. Now will it work? Yeah, it works. It works perfectly fine. Let's try to submit it. So yeah, we do have the solution. We have okay-ish runtime complexity. Yeah, that would be all. This was mostly implementation based. If you know BFS, you should be able to do this. So yeah, that was all for today. This was definitely a medium kind of problem, but I hope your day is going to be really easy. Thank you so much.